All right. Hello, everybody. Hopefully we're live. I think we're live. I don't know if Periscope is going to work today, but we're here. One thing is for sure, it is a beautiful day out. I mean, look at that blue sky here behind us. Beautiful day, blue sky. We got corn behind us out in the field, and even better, we got a payload. Look at this. Recovered. Yes. And very, very easily. Hey, Gregorius. You have to let me know how the stream is going. Wasn't sure if I was going to be able to stream out here. The bandwidth was kind of crazy. John's here. Hey, John. Yeah, so we were able to recover. There wasn't much of a recovery story because this is the easiest recovery ever. Like, it literally landed. So I'm on this side of the road. Here's where I'm parked on the side of the road here. It literally landed right there on the side of the road, like literally, I don't know, 3 feet from the side of the road. Like it was like right next to the road. We were actually afraid that it landed in the road at the time, but right across the road, like 3 feet from the road. I got a whole bunch of pictures. I took nice pictures and video from my nice camera, and I did take video of the landing as it was coming down. So I'll kind of recap what happened here and what we've been doing here for a little while here. But we've got the payload. It's here, successfully recovered. Everything's in pretty good shape. Let's see, what was just watching him fill the balloon. Yeah, we're here now. We're done with the balloon. The balloon is gone. Most of the balloon did not come back. We got just a little bit of a nub back from the balloon. So most of the balloon disintegrated and just kind of went into a whole bunch of tiny pieces. But we've got it back here. So let's talk about what happened coming down. So it pretty much came, the kind of cool thing, we were hanging way down there and it came from way up there. So it kind of just came from the sky and just followed the road, which was pretty cool. It was nice to be able to hang out and watch it come down. But unfortunately, one of the issues was my landing prediction system stopped working at like, I don't know, a couple thousand feet. I'm gonna have to go back and look and see what happened, but it stopped working, and I wasn't getting prediction updates, or at least not locally, and so we weren't exactly sure where it was gonna come down. But luckily we were close enough. We were just maybe, I don't know, a tenth of a mile down the road, so it was close enough where I could get my good camera out and actually get pretty good footage. It's only like a 5-second video, so the issue was, because I didn't know the landing, I wasn't getting the landing predictions. We were close enough, and then we didn't spot it until kind of late, maybe like 1,000 feet, 2,000 feet off the ground, and it came down. So, who's this? I can't see your name. Gary. Sorry, the sun's shining. Gary says, "Did the plastic antenna break?" Well, Gary, as a matter of fact, it did. There it is. There's the antenna. That's the video antenna that was providing the video stream. And yeah, it broke on impact. So the video antenna definitely shattered and just broke. But the good news is it broke in a good spot, which is kind of what I was a little bit worried about that. So I'll show you the inside of the payload here. Let's see, which way do I got to turn you here? Okay, so here's the inside of the payload. So this is right here. This is the other side of the antenna where the antenna hooks to, and you can see that it's broken off right there. But luckily, this is basically like the hinge that puts it at a 90-degree angle, and it broke right here at the hinge, which was kind of perfect because it sits in the box like this. It was tucked in there. I don't know, can you see? Let's see which way we gotta come this way so you can see it. So it kind of sits in the box like this, and what I was afraid of is it was going to hit the ground, smash into the ground, and then this thing would just like be thrown up into the payload and either hit the box, break the box, or worse, be thrown into the payload and then hit the flight computer, because that would be no good. But luckily, this thing was tucked right in there, and it stayed tucked right in there. So when we picked it up, it was just like that, stayed tucked right in, and it just broke off like in the box there. And so then you can kind of see the remnants there of the of the antenna. So that's the story of the antenna. So we'll have to get another one of those if we're going to do live video again. But that was pretty cool. We got, yeah, that did not survive. I'd like to get a little, I don't know. I think we need a different antenna for doing the live video. I mean, this is a dipole antenna here. And so Mike and I were talking about this a little bit, but, you know, generally there's a little bit of a signal void directly. This was mounted vertically like this, and directly below a dipole antenna, there's a little bit of a signal void. So that could have a lot to do with why we weren't picking up signal, especially when it was directly overhead. So we might try a different antenna. I don't know. I'll have to look and see what we should do for an antenna. So did get the cameras out. The cameras got awesome footage. I am super happy about the camera footage. It looks fantastic. One of them, so we have they're set at two different white balances. One of them looks amazing. The other one is good, but one of them looks really, really, really awesome, and I'm super happy about the video footage. Official altitude today, I think, was 100. I want to say it was like 103,300 feet on the dot. Let's see, dead zone, blind spot. Yeah. So we talk about the dipole antenna. So yeah, 103,300 feet was our official maximum that the onboard computer recorded. So we got to 103,000 feet today, which is just great. That's a good altitude to get to, especially for this payload. It was kind of on the heavier side. Let's see, what else can I tell you? Oh, the video system, the battery on the video system is actually still okay, and it still could work for a little while longer. So that lasted the entire flight transmitting video, which is good. So now we know that the video will transmit for the entire flight. Now we just got to figure out how to pick it up and how to receive it. That's going to be the trouble. Let's see, what else? Our little book plates here survived. So the book plates for Phil Stamper's book, The Gravity of Us. Those book plates survived the landing. They're a little bit banged up, but they, for the most part, that could be buffed out. That could be buffed out, right? No, they're in pretty good shape, but they survived and still intact, just hanging out there. They were wedged in here pretty tight. Let's see, when is the full weather balloon video going to be out? I should be. Hopefully, I can do that. I'm going to try to do it this weekend. I don't know if I'll be able to put a whole video together, but I'm going to try to do the video from this flight this weekend. How long did you transmit video? Well, as far as how long, we transmitted video for the entire flight, from start to finish. It transmitted. We had trouble receiving it. So I'm trying to read these comments. Will you try to archive the supersonic speed when the balloon is coming down? I'm not sure what you mean by that. So, I mean, this does not come down supersonic by any means. It does not come down supersonic. I mean, it comes down at a couple 100 miles per hour during the first couple of feet, but it was not supersonic. And then I saw somebody ask about the tarp that we put on. Is it for static electricity? It's a lot simpler than that. It's just for sharp objects, just so that you don't get like pieces of hay or dead grass or anything that pokes the balloon. So it's just trying to smooth out the surface, give you a nice surface to lay the balloon out, so nothing pokes it. So that's really what the tarp is there for. Yeah, there was something else I was going to say. Oh, the video. As far as the video stream, I think it worked about as I expected. I thought maybe we'd have a little steadier video stream for the beginning of the flight. It was kind of choppy and cutting out quite a bit, even during the beginning of the flight. But will you try to achieve 53 kilometers in a weather balloon? No, we can't get that high. He's asking about your video transmission setup. Okay, yeah, we'll talk about the video setup here in just a minute. So the I wanted to cut on the 53 kilometers. Yeah, we can't get to that altitude. That's not something that's achievable for us with the little latex balloons that we're using. I don't even know, I don't know kilometers that well since we Americans use the imperial system. I don't know why, but we do. But the 53 kilometers is definitely not achievable for us. I don't know if NASA could achieve that. I don't know what that is in imperial. That's got to be like... what is that, like 150,000 feet? Is that right? Somewhere in there, 160,000. I think NASA could achieve that with some of the bigger balloons, but we can't do that. So we're capped. Probably the highest we could go theoretically would be like 140,000 feet, but we probably won't ever do that. Using 4G to transmit video? No, so this is 2.4 gigahertz. So it's basically a Wi-Fi system. So let's talk about the video setup. So we'll show you the video setup, and I'll post some of this. I wanted to wait until after the flight before I posted some of the details about the live video system, but so here's the details on the live video system here for anybody watching here. So essentially, it's this Raspberry Pi here that's mounted to the side. There's a Raspberry Pi, there's a Raspberry Pi camera, and that Raspberry Pi camera, let's go which way? This way. Raspberry Pi camera is mounted right here on the outside, so it just kind of comes through the box, and it's mounted on the outside here. So that Raspberry Pi is there. That Raspberry Pi goes to a Wi-Fi adapter here, which is this guy, this Alpha Network Wi-Fi adapter. There usually is an antenna here that's attached to it, but as I mentioned earlier, that antenna is she broke. So it's a pretty simple setup. Raspberry Pi camera, external Wi-Fi adapter, and then we're using some software called Easy Wi-Fi Broadcast. And essentially, what that does is it's using the Wi-Fi adapter to just broadcast video over Wi-Fi. And the benefit there, so normally Wi-Fi is a two-way communication. You've got your access point or your router or whatever you have at home, and then your client, which is like your computer or your phone or your laptop or tablet or whatever. And usually they're having a two-way conversation. The laptop says, hey, I got some information for you. The router or whatever is replying back. Sorry, I'm missing these comments. I keep forgetting. I got to extend the timeout on the comments because they pop up and I'm in the middle of talking and then they go away. But anyway, so usually it's a two-way conversation, but that doesn't work so well when you're trying to do live video because you don't want the video transmission to stop, or you don't want the video transmission to have to rely on receiving a signal from the ground in order to keep transmitting. So it unlocks kind of that process, and it's just it just streams. It's just throwing video out there, and theoretically, if you're in the area, you could pick up the video with your own Raspberry Pi, even though we're from our balloon while we're receiving it. So anybody can receive it that's within reception range. And so it's just spewing data saying like, here, I got video for whoever wants it, free video, take it away. It's just streaming video data out to anybody that can receive it. And so the benefit of that is as the signal comes and goes, we can just point the antenna at it, and I think humidity was high enough there won't be any static discharge. Yeah, I don't know what the humidity is today. I'm sure I probably should know because it's in our flight data here, but yeah, so there's no two-way communication there. So as the video comes and goes and it breaks up, we can pick up where we left off and just keep getting more data. And so what I want to try to do, see, for the next time, what I want to try to do is drive with it maybe and try to stay with the video, or to try to, I don't know. I think we got to try different antennas. I think the setup is good, and that's kind of what we've learned today is that there's always this kind of, they always say there's two problems in engineering that you gotta figure out. There's a design. Is it a design problem or is it an implementation problem here? And so the design, I think, is good. What if you try to use two balloons in one instead of try? Yeah, so there's a lot of people that think about, like, whoa, you just use two balloons, you go higher. It doesn't really work out so well that way, because the balloons are still gonna break at the same at the same altitude. I mean, you could theoretically put less helium in, and you know, maybe it'll get a little bit higher. But then then one of the big problems becomes, as far as like a general, like how to do it by practice, is that once one balloon breaks, what do you do with it? Because if you're flying with two balloons with a lot less helium in it, like less helium per balloon so that they break later, eventually they're going to break, but then, you know, they're not going to break at the same time. So one will break, and then you'll still have one inflated. The one that's inflated won't be inflated enough to support the weight of the payload, so it'll either float or it'll gradually start descending and becomes a nightmare for planning purposes. So I guess theoretically you could get higher with two balloons, but I guess it's just it's way more difficult to manage two balloons than it is one. Generally, the easier thing to do would just be to get a bigger balloon, and then you can go higher. But even then, like the biggest latex balloons that we can get still aren't going to go, they're not going to go to 53 kilometers. We might be able to get it up to 140,000 feet. I don't know what that is. Might be like 40 kilometers. Maybe. That would be like crazy. That'd be like world record achieving. So let's see. It's on the bottom. I missed the comment. I just see Eddie Rux, or Gregorius replying to Eddie Rux saying it's on the bottom. I think he must be talking about the antenna. And I did see somebody said, can you just boost the Wi-Fi signal? This Wi-Fi adapter here is actually very, very powerful. But I think the problem is twofold. For receiving, the parabolic antenna would be best. If you use the Yagi in an array would be better. Yeah, so I think really this is just going to come down to antenna setup. I think in theory, so we started talking about the engineering problems. I think the concept was proven to work in theory. Because we were getting that choppy video, it meant it's possible for us to get video. Even we got a couple of frames at, you know, like 90-something thousand feet or something like that. So it's possible to get the video. And I think it's just going to come down to antennas. Like, what antennas should we be using? Can we do multiple ground stations for the antennas? Let's see. Can I see? Tori is happy with technical difficulties, enjoys sharing everything he learns. Yeah, I don't mind it. Problem with omnidirectional dipole antenna is that it has a donut-shaped lobe, so it's actually strongest going sideways, not vertical. Right. So that's kind of the issue that I started talking about a little bit, but Gregorius put it a lot more eloquently than I did. So yeah, dipole antenna, it basically has like a void at the end of the antenna. So this antenna, it's a dipole antenna, and it was mounted like this. And we started kind of thinking about this, and with a dipole antenna, you know, we mounted it like this, thinking that, what about if you use two different sizes? The first one solo, carrying a hole. Second, I can't read. Really hard. So I want to finish this here on the video, and then I'll try to get to some of the other comments here. But so it's mounted vertically on the bottom of the payload here. Just kind of sticks out. Well, sticks out like this, except upside down, not at the top of the payload. It sticks out the bottom. And so with a dipole antenna directly below it, we can't pick up signal. And so the theory was originally that, well, maybe, you know, since it's traveling horizontally, it might be best to have a dipole antenna. But, you know, now I'm thinking that it might even be better to have some sort of like I don't know. We gotta think about what kind of antenna that we want to have, because it might be best to have a like parabolic type antenna or some kind of high gain antenna on the bottom, because I don't know. See, you probably have a harder time receiving video at the lower altitudes, but a better time receiving video when it's at higher altitudes, because you'd have, you know, even if it's a directional antenna and it's got like a 20-degree beam, if it's 100,000 feet up, a 20-degree beam is going to cover a lot of space. So yeah, I think really what we got to do is we're going to have to address the antenna implementation, and then we can do this again. So I think number one is we got to figure out what antenna we're going to use on the payload. Are we going to use this again, or are we going to try something different? Number two is, what are we going to do on the ground station? So it was nice to have the one ground station. It was picking up a frame here and a frame there. But I think the key to doing live video from start to finish is going to be multiple ground stations. So if we can have a few ground stations going, then we might be able to pick up a little better, a little more video, and then stitch them together. And when it comes out in the stream, it will be a single unified video. So that's kind of the intent there. So I think that's doable. It's just a little more complicated. So, so that's the story on the live video. But I think the overall, like, yeah, it wasn't great. Like, you're not going to take that video and go play it on your TV probably. So it wasn't great. It was good for catching screenshots. If you could grab a screenshot during flight, when we had a couple of frames that came in clear, you could grab a screenshot, which was, I think that's still pretty cool, to even get those live kind of screenshots. It was more like live pictures than live video. Another idea is to beam the Wi-Fi signal to a sat and have that send back video. Maybe, yeah, you might be able to use like the Iridium constellation or something to do that. How many kilograms is the largest latex balloon? I think the largest latex balloon that we could possibly buy is like 3,000 grams. So 3 kilograms, I think, is the largest possible balloon we can buy. The largest one we actually buy is 1,500 grams, so 1.5 kilograms. But we could get larger, but you need a different inflation nozzle that's bigger, and we don't have one. I mean, we could get one, but I don't know. These balloons do just fine for us. At some point, we'll probably go bigger. So there. Oh, we also tested the cut down system again. I got nice video on my nice camera for that, but the cut down system also, and again, worked exactly like it should. So had gotten stuck in a tree, we could have used the cut down system and cut it down, and it would have worked perfectly. So we did test the cut down system again, but fortunately we didn't need it, because easiest recovery ever. Oh man, that was awesome. And I wish, if our live stream or our landing predictor was working correctly, or maybe if I wasn't so focused on the camera stuff, I might have been able to catch it. I mean, because it was literally like right on the side of the road. I could have just pulled over on the side of the road, like jumped out of the car. I probably could have sat in the driver's seat and just went like, ew. It was that close to the road. Like, I'm gonna walk over there. It's a good thing this is not a busy road, because I was like, as it was coming down, I had my camera, and I'm like standing here in the middle of the road, like taking pictures. I'm like, yeah, I'm taking pictures and videos as it's coming down. I'm like right in the middle of the road. Like, I hope there's nobody behind me. Yeah, problem is he's a one-man fight. Yeah, most of the time on launch days I'm by myself, which is a problem. So, yeah, that's it. That's another issue. The parachute worked just fine. It did get a little tangled, actually, which was interesting. I want to see. It's going to be hard because, see, we don't have the upward-facing camera. Normally, I would look at the upward-facing camera to see how the parachute performed, but we didn't have that today. I did take it off. It's in the car now. But I took some photos and videos. I'll post them online later. I took a bunch of nice photos and videos, so hopefully we got something. But yeah, so this is where I'm standing, like on the shoulder of the road. It landed right here. Standing in the landing spot, like right there. So awesome. When is your next weather balloon launch? That's a good question. I don't know. I gotta look it up, because there's a chance there's actually another really good launch day like 2 days from now. And I don't know, this kind of has me amped up. I'm pretty excited about this live video. So I don't know. We have not planned it yet. It was supposed to be, the next launch was supposed to be in August. So we're gonna break for a couple weeks and get ready for the next launch and do it in August. But I don't know. I really want to try that video system again and see if we can correct some of the issues that came out of today. So I don't know. We may try to do one sooner rather than later. I got to get home and got to think about it. Think about when we can feasibly do it. So let's see. I got to make sure I don't cover the camera when I'm trying to shield my eyes and the phone. It's so bright here, which is kind of nice because it's a beautiful day, and that's going to contribute a lot to the awesome photos and videos that we got. So that's another reason why I'm kind of torn about, do we do another weather balloon launch? Like, if I think the next good day, I don't remember if it's Sunday or Monday, but do I do another one like right away, or should I take the time and edit the video from today? I don't know. That's gonna be the big question. Let's see. Are you planning on streaming any NWS balloon chases again? Yes, I do plan on streaming that again. I haven't done one in a while. Actually, it's a lot harder to get those in the summertime. Yeah, so Trippin' Fool's talking about hard to get people to help. Yeah, it is hard to get people to donate their time. You really got to get somebody that's interested. So special thanks to Mike today. Mike drove all the way up, you know, like an hour and a half from home to come be a part of it today, to come help out. He didn't have to do that, so that was super nice of him. So you can thank @Hojo on Twitter for helping me out today. It's always nice to have an extra hand to help out with some of the stuff. I do try to optimize this so I can do it all myself. But you know, it's always nice that I would prefer to have help, but I know that most days I don't. So I try to optimize everything so it's possible to do it myself, but there's a lot of things that can be done if there's multiple hands. Like catching the payload, there's a chance I could have done that if I wasn't focused on taking the photos and videos. So I got a new camera, so I was trying to utilize that. And I did not expect it to land that close to the road. It's never done that before. That was pretty awesome. Like, so yeah, we're gonna, I'm gonna head home, and we got another stream later tonight. Hopefully it's a SpaceX stream. We're gonna talk about SpaceX tonight, after the launch, not during launch, but after the launch. Why are the NWS balloons harder to get in the summer? Oh yeah, I kind of mentioned that, but I didn't follow up on that. So that's a question from Austin. So in the summertime, the summer wind patterns typically, like today's weather pattern was actually pretty typical of the summertime. You see this a lot in the summertime, where it goes to the east and then it loops back to the west, and then it kind of lands towards the east. So the reason why it's harder is they launch in Buffalo and they don't quite reach close to home in the summertime. So the wind's just not strong enough to get it here, and I prefer to catch them close to home. Let's see, I bought one time the largest balloon that I can buy. Quick launch, estimating the pressure altitude to reach 14. I'm not sure what that means about the pressure there, but anyway, so yeah, going back to the NWS balloons, in the summertime, the winds just, well, it actually blows out here, but then the upper level winds actually blow back to the west, and so it blows it back to the west, and then it, you know, comes a little bit to the east to land, but not quite to east side of Rochester where I am. So that's the tricky part. In the summertime, you don't get a lot of days. It's better for launching our balloons because it stays kind of close to home, but you don't get a lot of days where the National Weather Service ones come all the way out here. It still happens from time to time, but usually get more of those in the spring, in the fall, and even in the winter. The winter actually it can blow past us and go out to, you know, like Utica or Syracuse or somewhere in that region. So the winter time they can go really far, but like spring and fall, you can get a lot of NWS balloons from Buffalo that land in this area. But I'm sure we'll do another one. Thanks, Tori, for sharing your weather balloon launch. With all of us, I would like to launch a weather balloon one day. Thanks for the inspiration. Yeah, for sure, Eddie. Check out overlookhorizon.com/how-to. You know, the biggest thing is there's a lot that goes into it, but the biggest thing is you just got to go for it. Just dive into it. You just take one step at a time and just learn each process. I mean, it took me, the very first time we did this years ago, it took me a couple months to get ready and understand the process and really understand what was happening. So it took months of getting ready, and now at this point we can pretty much get things organized in just a couple of days. But that's because we have, you know, the plans in place and the payloads in place and all that kind of stuff. So, but yeah, go for it, do it. I mean, it's so, I have a ball with it. Obviously, you guys can probably tell I have a ton of fun launching these things. It's a lot of fun to recover them. Sometimes there's a lot of stress. But especially when you get something like this, like I'm just beaming with joy right now at how easy this was to recover. It's awesome. I thought if the insurance company drone commercial picture, Thought if the insurance company drone commercial picturing Tori's payload doing the same. I'm not familiar with this. What else can we talk about? Yeah, I mean, I think we covered it all. That was awesome. So, anyways, here's the plan going forward. So we're gonna have another stream later tonight. Hopefully, it's a post-launch chat. Do you know a company that makes balloons bigger than 3 kilograms? I don't know. I don't personally know the company. There are companies that make bigger balloons. I mean, those are the company like Raven Aerostar. Actually, I guess I do know one. Anyone in Northern Illinois would be interested in an NWS chase on a balloon, hit me up. Austin? Is that Austin? Oh no, A-Web. A-Web wants to chase an NWS balloon. Why haven't you been able to use nitrogen gas yet instead of helium? I think you're talking about hydrogen gas. It's not that we haven't been able to. We haven't ordered any yet. We still got a lot of helium. We got a lot of helium tanks. And so we just haven't gotten to it yet. We still have a lot of helium, but we are preparing to switch to hydrogen. It probably won't happen until maybe like next year. Maybe later this year, but I doubt it. I think we got enough helium to do all the rest of the flights we want to do this year. So yeah, we got a live post-launch chat tonight after the SpaceX stream with Sandy and Chad. Hopefully, if it launches tonight, only 20% chance of launch tonight, so I'm not feeling great about that. But hopefully it'll be there because I do want to give you a little sneak peek of the video. If not, I'll put together some video this weekend and hopefully get it posted soon. Yeah, some people talking about the max weight. So yeah, if you're asking, I guess the other thing, if you're asking about balloon sizes, you also got to keep in mind that the maximum weight that you're allowed to fly without special permission is 6 pounds for a single payload box. You can launch up to 12 pounds on multiple payload boxes, but any single payload box can only be 6 pounds at most. Let's see. Is there any benefit to using hydrogen? And are you on Patreon? Yes, we are on Patreon, actually. We've had Patreon for a long time, but I haven't really been messing with it. But I did, just recently I updated all our Patreon stuff like a week ago, and I'm going to try to start using that a little bit more. So we do have a Patreon, patreon.com/overlookhorizon. If you want to support the group, and I have been posting some behind the scenes stuff. Actually, as we were testing the video system, you didn't know this, as we were testing the video system, I was doing tests, live broadcasts on Patreon only. So if you do want to be a Patreon supporter, I'm going to try to do some of the behind the scenes stuff, like while we're testing and stuff like that, and do that exclusively to Patreon. So if you want to go to patreon.com/overlookhorizon, you can support us on Patreon, and you'll get some of that behind the scenes footage. And then, so somebody asked about the benefits of hydrogen. Yeah, actually, hydrogen does have a little bit better lift, so that you need less gas to get the same amount of lift as helium. So actually, hydrogen is a better gas to use as far as lift goes. It's just the big kaboomy boomy part that's the tough part of hydrogen. And really, it's not that big of a deal because we'd be using almost pure hydrogen, not completely pure hydrogen, but almost pure hydrogen. It's like a hydrogen, I think it's hydrogen nitrogen mix, but it's mostly hydrogen, like 90-something% hydrogen. And so there's not a lot of oxygen in there. So if it burns, it's going to burn relatively slowly. It's not going to be an explosion because it's going to burn basically from the outside in. I mean, it happens really, really fast. But it burned from the outside in, and you would get a slow burn. And it's also lighter than air, so as it's burning, it's going to rise. And really, the biggest risk from a hydrogen balloon explosion is going to be the raining debris of latex that could be on fire. So that's kind of the issue there. But yeah, it's way less expensive. Those helium tanks, one helium tank costs us about $400 US. And that gets us 2 launches. So it's about $200 per launch in helium. Hydrogen, the same size tank, is I think $27, and that would get us 2 launches. So you're talking like, like $14 per launch as opposed to $200 per launch for hydrogen versus helium. So there's a big cost difference. But if you're going to do a launch, and especially if you're not experienced with doing this yet, don't start with hydrogen. Start with helium. Get the process down, like know what you're doing, so that you can so that the other stuff becomes routine, and then you can focus on the safety aspect of using hydrogen. The humanity. Somebody's talking about the the Hindenburg, right? Yeah. So I mean, it's pretty much kind of the idea. Eddie wants to make a monthly small donation. Well, thanks, Eddie. I appreciate it. Yeah, you can join our Patreon, or you can also go to overlookhorizon.com/donate. If you do the donate, if you're in the U.S., you can actually get a tax write-off for it because we're a 501c3 nonprofit, and so it's a tax-deductible donation. So if you do the overlookhorizon.com/donate, you'll get a tax-deductible donation. If you do Patreon, that's not tax-deductible, but you can do Patreon and you can get behind-the-scenes footage. So whichever you prefer. But appreciate it. Appreciate the generosity. That's awesome. It's really nice to be able to do this kind of stuff and share it with you. And I do want to improve on this live video. I was super pumped about it, even with the choppiness of it. I'm very optimistic that we can get this to work going forward. Oh, that's why I was asking about the static spark, says Trippin' Fool. Yeah, it's a good question. I don't know. I haven't really looked into it for that reason. So I think our plan is, if we do use hydrogen, we're actually going to use a grounding strap like around our wrist while we're filling the balloon, and so hopefully that would help mitigate any static discharge. We'd also, we'd be trying to discharge ourselves before we started filling the balloon, and then we put a grounding strap on around our wrist while we're filling the balloons. That's the plan for making, because that is the biggest risk for helium or hydrogen is a static spark setting it off. So I mean, really, like, we don't have anybody smoking in the area. Obviously you don't want to be smoking in the area. You don't want to have any open flames or any, you don't want to have a torch or fireworks or any of that kind of nonsense. But yeah, a static spark would be the biggest issue for hydrogen. So all right, well, I think I'm going to wrap this up, everybody, because I'm hot, I'm starving, I have not had lunch yet, a little bit tired, but we had a lot of fun. This was awesome. Easy recovery, and here it is once again. That's our payload, back from 103,000 feet. What does it says? No balloon. I think he's more concerned about the tarp causing this. Oh, the tarp causing the static spark. Oh, that's a good question. It's a good question. I'll have to look into that. It's possible. It is a good concern. All right, so I'm going to wrap up here. There's our payload, back from 103,000 feet. I'll put all the statistics. That stuff I can get up really easily. That'll be up in like an hour or two on overlookhorizon.com and /18 for this flight number 18. So if you go to overlookhorizon.com /18, you'll see the statistics from this flight in just a little while. I usually post things like, what the max altitude was, but also like max speed, max temperature. There's some graphs about the humidity. There'll be a skew-T graph up there, hopefully, if you're into meteorology. And so I'll post all that stuff. That I can do all that really, really quickly. And then we can actually we'll see the actual flight path versus the predicted flight path, which was a little bit different. So I'll have all those up probably within maybe like an hour or two. Those can go up pretty quickly. So yeah, there we go. I'm gonna head home. I'm gonna start doing that stuff, and then hopefully see you guys later tonight for the SpaceX stream. I'm trying to put my hand here so I can see the comments. Well done, man. Been following you for a couple of years now. Keep it up. Wow. Well, thank you very much. Yeah, I appreciate everybody hanging out and joining us this morning for the excursion. This was a lot of fun, and I can't wait to actually show the videos to you, because I took a quick preview. And it looks awesome. The videos look awesome for today. So I will get that out soon. I'll definitely have some photos out today. The video will probably be a little bit longer, but I'll definitely have photos from today's flight out. Probably all day is just going to be photos coming. Probably post one as soon as the stream is done, because I got a bunch of ground photos to share, some in-flight photos that we'll share, and yeah, we had a good time. So All right, thanks everybody for joining us. Join us tonight after the SpaceX launch. Follow us on Twitter and Facebook for the updates, so you can know if that's actually happening tonight. And then hopefully we'll see you tonight after the SpaceX launch, and then we'll do more of this soon. All right, thanks everybody for joining me. My name's Tori. This is Overlook Horizon, and we'll see you guys soon. All right, thanks guys. Goodbye.